because that's all I'm looking for. So doing all the simplifications and doing additional steps, they're fine, but I'm just looking for the basic steps. All right, we're up to the last one. The last one is not the same. The right-hand side of line 4 refers to the left-hand side. If you look at line 4, y gets y plus 1. So that's why I can say that the right-hand side, y plus x, refers to the left-hand side, which is just y itself. So I can't really use the same argument and use the forget operation. In this case, we have to try to find the inverse function. Okay, so we can say the right-hand side, and we'll give it a name, f of x equals, f of y equals y plus x. Now, why do I pick y here? Why didn't I pick x? Because y is the variable on the left-hand side. Okay? So we want to look at things from the perspective of variable y, because that is the one being changed. So the right-hand side, f of y equals y plus x, has an inverse. F prime of y, how do we reverse the operation of adding x to y? Subtracting x should do it. So the inverse operation is y minus x. We have to apply the substitution operation. Okay, if you want to be really abbreviated or really brief, you can just say use sub. Okay, that's fine. Okay, so now we have to say post 4 is based on the substitution of pre 4. We are looking for occurrences of what? Y. We're replacing each occurrence of y with what? F prime of y. Okay. Now I would not jump a step here. I would just say f prime of y. Do you know why? Because if anyone figures out the wrong inverse function, and that person applies it directly here, then I would not be giving that person the point. On the other hand, if that person quotes f prime of y and it is the inverse function, then I know that person knows that we are supposed to use the inverse function in the substitution instead of the other function. Okay, so that's why it is important to go only one step at a time, so that if you mess up one step, the other steps will still give you partial credit. Okay, so the whole thing now becomes the substitution of pre 4, and pre 4 in our case is this mess here. So we just stash the whole thing here and say that we are substituting y with f prime of y, and f prime of y is y minus x, just like that. Can someone tell me what is the result of the substitution? Is there anything to substitute? Does pre 4 mention anything about y, at least the way I do it here? Nope. Well, since it did not mention anything about y, the substitution operation becomes kind of pointless, because I cannot replace any occurrences of y with the inverse function applied to y. So that means after the application of the substitution, I get the original thing back. I could not say anything about y anymore. Okay. Now, is this correct? I mean, since I could have, made the conclusion of y equals to 9 at this point, if I had kept, the fact that y equals 6 earlier, is this conclusion wrong? In other words, every single time in this algorithm, after line 4 executes, is this condition still guaranteed? Yeah, it is still guaranteed. It is just not as specific as also saying that y equals to 9 at that point. Okay? Which means the post condition is still correct. It is just not as good as a post condition as the one where I can say, oh, by the way, y is going to equal to 9 at this point. Because if I did it the other way, I would have been able to say that y equals 9 at this point. Yep.
How does y equal 9 at this point, if given that it was previously equal to 6, you applied the substitution method?
Okay, I can show you.
You got 6 minus 3,
Okay, I can show you the alternative. Okay, so the square brackets will basically denote, what if we push it one more step and say that since we know x equals 5 and y equals x plus 1, y equals 6. Okay, so is this okay? Does everybody understand why if I push it one more step, I can make that conclusion? Okay, so let's just say that, we kept that conclusion and we have the, optional derivation based on that fact. Okay, so that will make this one a little bit different because the forget operation will now become x equals 5 and y equals 6, right? Because my precondition is now different. And we are still forgetting, any components only mentioning x, that has any mentioning of x. And we are still concluding after the operation x equals to 3. So the end result of this forget operation is we do have one component to forget. We have to forget that x equals 5. But we get to keep the fact that y equals 6 from the precondition. So the end result of the forget or the entire derivation, at least at this point, is y equals 6 and x equals 3. Now, if I take this one as my post 3 and apply as my pre 4, the derivation of my post 4 will be different. So once again, the square brackets denote, the alternative path of the derivation. So in this case, we will still have, this is equal to the substitution of something, but because post 3 or pre 4 is now in this form, I have to do the substitution based on y equals 6 and y equals 6 and x equals 3, and we are substituting occurrences of y by y minus x. Is that okay? The only change with the alternative path is instead of expanding pre-4 into true and x equals 3, I'm expanding pre-4 to y equals 6 and x equals 3, which is consistent with my other alternative branch. So following this, if you carry out the actual substitution, then it becomes y minus x equals to 6, right? And x equals to 3 does not mention anything about y. It gets to be preserved. But what about this statement here? Okay, you can say that y equals to 6 plus x and x equals 3. Since I was able to push it earlier and say that since I know x equals 5, y equals x plus 1, then y equals 6, I can use the same method here. So that if I know x equals 3 and y equals 6 plus x, then I can also conclude and say that y equals 9 at this point and x equals 3, because once again I can decouple the relationship between x and y. Yep. You mean this part here? This one is the inverse function. Oh, I'm adding x on both sides of the equation. You mean from here to here? Okay, let me highlight it.
Talking about the substitution of y minus x into y.
Because I'm replacing occurrences of y with y minus x. That's the substitution operation. Are we looking at the right lines? Are we looking?
He's substituting that y minus x back into what the y is. So he's not saying it's 6, he's just putting it back in.
It's not substituting the value of y, it's substituting what y itself is. So rather than y equals y minus x, it's y minus x equals 6.
It is a syntactic operation, not substituting the value. So everywhere I see y in the precondition, I replace it with y minus x. It's basically like using a text editor. You search and replace. Yep.
I'm just a little confused from earlier where line 2 didn't refer to the left-hand side, but line 4 does refer to the left-hand side.
Because the right-hand side of line 4 is y plus x.
Okay.
The left-hand side is y.
Okay.
y plus x mentions y, and y is the left-hand side. So that's what I meant when I say the right-hand side refers to the left-hand side.
So line 2 said x plus y, and if you wanted to x, then we'd say refers to.
Line 2, as it is right now, does not
Yeah, it
refer.
doesn't, but if the y value was x, then we would say it was, if we switched y to x now.
Correct, yes. If you change one or the other side to use the other variable, then you can use the same argument, yes. Yep. So let me just make it a point here and basically say when TAC says the right-hand side refers to the left-hand side, he means the expression on the right-hand side uses the same variable being updated on the left-hand side of an assignment statement. Okay, I'm just spelling out what I meant by the right-hand side refers to the left-hand side. Okay, are we good on this one? So once again, the stuff in square brackets, those are all optional. Okay, it does give you a better result because if you use the square brackets, the alternative derivations, not only does it tell you that x equals to 3, it also tells you that y equals to 9. But it does not mean the other way is wrong. The other way is just giving you an answer that is not as specific. Okay, the other one is still right because x is guaranteed to be 3 by the time we finish the entire algorithm, but it has lost track of y in the process. It is still true, it is still right, it is not as good as a post condition as the one that can still give you, some idea of what y should be. Okay? Are we okay so far with the pre and post condition stuff, the forget rule, the substitution rule? Yes?
I had a question on your original derivation.
Okay, so we are going way back.
The true and
True and anything? Mm-hmm.
at the bottom.
Oh.
Shouldn't you also have y equals y plus x?
No, you do not want to have that, okay? Okay, y equals y plus 6 is a condition that can only be true when x equals to 0. When you use the substitution rule, you don't append and say, and y equals y plus x, okay? So if you look up the notes, the templates, tells you that when you use the forget rule, then you append and the variable equals whatever is on the right-hand side. When you use the substitution rule, you do not append a conjunction next to it. Okay, because that would basically defeat the whole purpose of using the substitution rule. Exactly. Or if when you have a line that says x equals x plus 1, then you'll be appending x equals x plus 1. But x equals x plus 1 is something that cannot happen, and that basically just turns your entire post condition to false, which is not what we are trying to do. Okay? Are there any other questions about this one before we move on to the last example question? Now, in the test, obviously, it will not be the same question, okay, for sure. I will probably ask you something that includes not a loop, because loop invariants are really nasty, but maybe a conditional statement. Okay, so you have to remember when you see a conditional statement, how do you start with the precondition and end up with the post condition? Okay, we did a few exercises in the class. There's one in the textbook as well. If you have questions, bring it on in the next class. This is why I have the practice test arranged exactly 1 week before the actual test, so that you have some time to study a little bit, you have some time to prepare your question, and we will still have 1 class meeting before the test, so that if you have any additional questions, you can bring it in the next class meeting, and we still have a chance to talk about it before the actual test. Okay? So it means that